In this review tape, we will go over the second half of our final review on intermediate algebra. Okay, the first problem is the following. Solve for x. 8 minus 3 times x minus 2 in parentheses equals 5 minus, in brackets, 1 minus, in parentheses, 4 minus 2x. Close parentheses, close brackets. Okay, now we have to remember order of operations, which tells us that we don't make 8 minus 3 5, but rather this multiplication has to be performed before the subtraction. So we have here 8 minus 3x plus 6, distributing the minus 3 through the parentheses, equals 5 minus, now I'm going to leave the brackets, but I'm going to remove the inner parentheses here, 1 minus 4 plus 2x. In other words, I'm distributing a minus 1. Minus 1 times 4, minus 1 times minus 2x. Okay, now I'm going to collect like terms, combine them. 8 and 6, that's 14 minus 3x equals 5 minus, now in the brackets I have 1 minus 4, that's minus 3 plus 2x. And here 14 minus 3x is 5, minus a minus 3, that's 5 plus 3, and minus 2x. In other words, we're distributing a minus 1 through the brackets. So 5 plus 3 minus 2x. Or 14 minus 3x is 8 minus 2x. And now we're going to solve for x. We want to get x alone on one side of the equation. So we can add 3x to both sides of the equation. This will give us 14 equals 8 plus x, and then subtract 8 from both sides of the equation, giving us 6 equals x, or x equals 6 is our answer. And of course we can check it in the original equation, and if we do that, it does work out. Next, we have an inequality. We want to solve for x and sketch the solution set on the number line. And we have the following: 3 less than or equal to 7 minus 2x over 5 less than 7. Okay, now in a problem like this, we'd like to get x alone in the middle, okay, for the inequalities. And working with an inequality, we can follow much the same rules as working with an equation. Addition and subtract, we can add or subtract the same quantity to all parts of the inequality. That's no problem. When it comes to multiplication and division, if we multiply or divide by a positive quantity, that's fine. If we multiply or divide by a negative quantity, we have to reverse the direction of the inequality. I'd like to start here by getting rid of fractions, and I'm going to multiply all parts of the inequality by 5, a positive number, so that's okay, giving me 3 times 5 less than or equal to 7 minus 2x less than 7 times 5. Multiplied each part of the inequality by 5, and of course maintained the same direction, since I was multiplying by a positive number. 3 times 5, that's 15, less than or equal to 7 minus 2x less than 35. Okay, now I'm going to subtract 7 from all parts of the inequality, also a legitimate thing to do. 15 minus 7, that's 8, less than or equal to minus 2x, less than 35 minus 7, or 28. Now the idea is to get x alone in the middle here. To do that, I have to divide through by minus 2, but since I'm going to divide by a negative number, I'm going to have to reverse the directions of the inequalities. Okay, so let's see, I have the 8 minus 2x and 28. I'd like to divide through by minus 2 to get x alone in the middle, but I have to reverse the directions. This less than or equal becomes a greater than or equal. This less than becomes a greater than. And I have minus 4 greater than or equal to x greater than minus 14. Okay, now, instead of writing this, that minus 4 is bigger than x, which in turn is bigger than minus 14, I prefer to rewrite the inequality in the following way. So we had this. I'd like to rewrite it as minus 14 is less than x, less than or equal to minus 4. This is particularly easier if you're going to sketch the solution set on the number line. Okay, if minus 4 is bigger than x, and that's bigger than minus 14, then minus 14 must be smaller than x, which is smaller than minus 4. So therefore, we now know that the answer is someplace between minus 14 and minus 4. Minus 14 is excluded. Minus 4 is a possibility, is acceptable. So on the number line, we have the following. Here is 0. Here would be minus 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we want all those values between minus 14 and minus 4. This indicates everything between minus 14 and minus 4. And furthermore, minus 4 is acceptable, so we fill it in over here on the minus 4. In problem 3, we want to solve for x. The following equation involving absolute values. 3x minus 5 in absolute value minus 1 equals 6. Okay. The way to handle something like this is to isolate the absolute value part of the equation. So I'm going to start off by adding 1 to both sides and getting that the absolute value of 3x minus 5 is equal to 7. In other words, the absolute value of a number is 7. That tells me that the number was either originally 7 or the number was minus 7. If a number without its sign is 7, that number, which is represented by 3x minus 5, was either 7 or minus 7 to start out with. And when you took the absolute value, you got 7. Okay, now, don't feel that you can do something like this to begin with. You can't say 3x minus 5 minus 1 is 6. 3x minus 5 minus 1 is minus 6. It's only when you have the absolute value isolated on one side that you can make this statement. If a number without its sign is 7, then it's either 7 or minus 7 originally. But it has to be isolated first. Okay, so we have here adding 5 to both sides. 3x equals 12. X equals 4 as one possibility. And here, adding 5 to both sides. 3x equals minus 2. X equals minus 2/3 as the other possibility. And checking them, going back to the original equation here, for x equals 4, you would get the absolute value of 3 times 4 minus 5 minus 1 should be equal to 6. And here you'd have 12 minus 5, the absolute value of 7 minus 1, and 7 minus 1 would give you 6, so it checks out. And on the other side, on the minus 2/3, we'd have 3 times minus 2/3 minus 5 in absolute value. Minus 1 should be equal to 6. And here we would have the 3's canceling. Minus 2 minus 5, the absolute value of minus 7 minus 1 should be equal to 6. And of course, the absolute value of minus 7 is the same as the absolute value of 7. It's just 7. 7 minus 1 does equal 6, and it checks out. The next equation, we want to solve for x, and we have x plus 6 times x minus 2 equals 7x plus 16. Okay, don't think that you've gotten anything by having it factored in this form. This is no use to you. You need, for example, in a quadratic equation, you want the product of two binomials, say, equals 0. Then you can set each factor equal to 0. But here, having this product equal to 7x plus 16, you have to start by multiplying it out using FOIL, bringing it all over to one side, and then working on the quadratic equation. So multiplying this out by FOIL, we get x squared minus 2x plus 6x, that's plus 4x, minus 12 equals 7x plus 16. And to solve a quadratic equation, for a first degree equation, we know we like to try to get x alone on one side, everything else on the other. But this is going to be a quadratic equation. We'd like to get everything on one side equal to 0. That is in standard form. And then we'll take a shot at factoring it. OK, so let's subtract 7x from both sides of the equation. And also let's subtract 16 from both sides of the equation. This will give us x squared, 4x minus 7x minus 3x minus 28 equals 0. And now we want to factor this trinomial, and we're going to try, so we're looking for two numbers that multiply to minus 28 and add to minus 3. They are minus 7 and plus 4. And checking that by FOIL, we have x squared plus 4x minus 7x, that's minus 3x minus 28. Now, this is altogether different from what we had here. The product of two numbers is 0, then either the first number is 0 or the second number is 0. So we have either x equals 7 or x equals minus 4. And these can both be checked in the original equation, and they will check out. In the next problem, we want to solve for x. And here we have a quadratic equation, 2x squared plus 3x equals 4. So we start by saying 2x squared plus 3x minus 4 equals 0. And you can try to factor this trinomial into two binomials with integer coefficients, but you won't succeed in doing so. Okay? You can try all the possibilities for the first terms and for the last terms, but it doesn't work. Okay, having failed at that, I'm going to use the quadratic formula. I'm going to say that this is in the form ax squared plus bx plus c equals 0, in which case the solutions can be gotten by the quadratic formula, that is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Matching this up, we see that in this instance, a equals 2, b equals 3, and c equals minus 4. So we get that x equals minus a b, minus 3, plus or minus the square root of b squared, that's 3 squared, minus 4 times a, which is 2, times c, which is minus 4, all over 2a, 2 times 2. Okay, that gives us minus 3 plus or minus the square root of 9 minus 8 times minus 4, that's plus 32 over 4. And that gives us a final answer of x equals minus 3 plus or minus the square root of 41 over 4. And you have two answers, therefore, minus 3 plus the square root of 41 over 4, and minus 3 minus the square root of 41 over 4. In 6, we want to solve the following equation for x. 5 over x squared minus 5x minus 14 plus 3 over x minus 7 equals minus 1 over x minus 2. Okay, and to start off, we see these fractions. We'd rather not deal with them, so we're going to try to clear fractions by multiplying both sides of the equation by the LCD. To determine that, we'll have to factor each denominator completely. These are already in good form, but over here, we'll have to factor this into two binomials. We're looking for two numbers which multiply to minus 14 and add to minus 5, and they are minus 7 and plus 2. Checking this, we have x squared plus 2x minus 7x, that's minus 5x minus 14. Then the LCD, we'll take each factor, the greatest number of times it appears in any one denominator. We need x minus 7, we need x plus 2. We have the x minus 7, and we need x minus 2. We need both the x plus 2 and the x minus 2. And we're going to multiply both sides of this equation by this quantity, which means each term gets multiplied by this. Okay, so if we're going to multiply through by x minus 7 times x plus 2 times x minus 2. The first, okay, let me just make this a little bigger so you can see it. Okay, I'll put it over here for you. We're multiplying through by x minus 7 times x plus 2 times x minus 2. Okay, each part gets multiplied by that. So when it comes to the first part here, the x minus 7 and the x plus 2 cancel out, so we have 5 times x minus 2. Plus, now in the second term here, the x minus 7's cancel. We have 3 times x plus 2 times x minus 2 equals minus 1 times, here the x minus 2's cancel, so we have minus 1 times x minus 7 times x plus 2. Just make sure you can see this because there's a crack here on the board. Okay, it's minus 1 times that. Okay, just one thing here. When you're multiplying through, okay, like for example, let's say you multiply this term first. Don't actually cancel the x minus 2's and then not have it left over here. In other words, each term gets multiplied by all 3 of these factors. Okay, so here the x minus 2 goes. You're left with minus 1 times the x minus 7 times the x plus 2. Then you start fresh over here. The x minus 7 goes. And on the last one, the x minus 7 and the x plus 2 go. Okay, at least now we have an equation without fractions. All right, so let's see what we can do. We can, let's save the 5 times x minus 2. Let's take these two, the ones that have the two binomials. Let's handle those first. This, when you multiply it out, you get x squared minus 2x plus 2x at 0x minus 4. And here minus 1 times x squared plus 2x minus 7x, that's minus 5x minus 14. Now we'll multiply in each case through by the constant. We're going to distribute the constants, giving us 5x minus 10 plus 3x squared minus 12 equals minus x squared minus 1 times minus 5x, that's plus 5x, minus 1 times minus 14, that's plus 14. Okay, on the left we have, let's see, 3x squared plus 5x minus 22, combining these constants. And on the right, minus x squared plus 5x plus 14. For a quadratic equation, we like everything on one side equal to 0. So I'm going to add x squared to both sides. I'm going to subtract 5x from both sides. And I'm going to subtract 14 from both sides. This, of course, will give me 0 on the right-hand side, which is what I want. And let's see what I get on the left. I will get 4x squared. The 5x and minus 5x go. Minus 36 equals 0. Okay, 4x squared minus 36 equals 0. You can factor, the way we do all our most of our quadratic equations, or because there is no first degree term, we have another option here. We can solve this by extracting roots. We can say 4x squared equals 36, divide both sides by 4, x squared equals 9, x is plus or minus the square root of 9 or plus or minus 3. Two possible answers. Or this, you could have factored, this would be, you could have pulled out a 4 and then it would have factored into x plus 3 times x minus 3. You would have gotten the same two possible answers. Now, on a fractional equation where there are variables in the denominators, and also on problems which you say square both sides of an equation you have involving a square root, you must check. It's not only to make sure you haven't made an algebraic mistake, but it's to make sure that in solving the problem you haven't introduced any extraneous solutions, any spurious solutions that are not really solutions to the original problem. See, what we were solving was really this multiplied out. Okay, and that we've made certain assumptions when we do that, and we have to make sure that this answer makes sense to the original problem. Now, actually what we're checking for is to make sure we don't have any divisions by 0. If, when you plug in, you don't get division by 0, you're probably all right. You just have to check, the rest is just to check the arithmetic and the algebra. But if you do get division by 0, if the thing cannot be checked because it doesn't make any sense, and you have to knock out that possible solution. So that's over here. Let's do the check. We have x equals 3 and x equals minus 3 to worry about. Going back to the original equation, if you plug in x equals 3, you get 5 over x is equal to 3. So you'd have 9 minus 15 minus 14. Plus 3 over x minus 7. 3 minus 7, that's minus 4. Should be equal to minus 1 over x minus 2. 3 minus 2 is 1. And let's see what we get here. We have 9 over minus, okay, 5. Let me finish this up here. 5 over, now we have 9 minus 29. So we have minus 20. And here minus 3/4 should be equal to minus 1. This is minus 1/4 minus 3/4, and that of course does equal minus 1. We have minus 4/4, which is minus 1. Now the other one, x equals minus 3, just write the equation again. 5 over x squared minus 5x minus 14 plus 3 over x minus 7 equals minus 1 over x minus 2. Substituting in x equals minus 3, we get 5 over 9 plus 15 minus 14, because minus 3 times minus 5 will give us plus 15, plus 3 over minus 3 minus 7 should be equal to minus 1 over minus 3 minus 2. Okay, we have 5 over 9 plus 1, so 5 over 10, and here plus 3 over minus 10. So 5/10 minus 3/10, that's 5/10 minus 3/10, 2/10, or 1/5. And on the right side here we have minus 1 over minus 5, which of course is 1/5, so it does check out. This is example 7. Solve for x. The square root of 3x plus 4 plus 2 equals x. Okay, here we have a square root. We're going to square both sides, but not in this form. First we're going to isolate the square root. It is wrong. You can't just say, well, I'll square this, and square this, because if you were to square both sides in this form, it would be a binomial, and you would have the inner and the outer terms, of course, which would still involve the square root. So you first have to isolate the square root. 3x plus 4 is x minus 2. I've subtracted 2 from both sides. And now I can square both sides. This will give me the square root of 3x plus 4 squared is just 3x plus 4 equals x minus 2 squared, which is x minus 2 times x minus 2. That is x squared minus 4x plus 4. And quadratic equation, getting everything on one side equal to 0. I will subtract 3x from both sides and also subtract 4 from both sides of the equation. This will give me 0 equals x squared minus 7x. And this is a particularly easy quadratic equation to factor. Since we have a common factor, there's no constant term, so we can just pull out an x. And we get two solutions, x equals 0, x equals 7. And these both have to be checked. It's particularly important, okay, as I said, in fractional equations where there are variables in the denominator, and also in equations involving, say, square roots, where you've squared both sides. You may not have done anything wrong, and still you might have introduced an extra solution that's not a solution to the original problem. Okay, so let's check. If we check x equals 0, we get that the square root of 3 times 0 plus 4 plus 2 should be equal to x, which is 0. And here we have the square root of 4 plus 2. Now the square root of 4 means just the positive square root of 4. Okay, this is not a minus 2, it's just a plus 2. So 2 plus 2, and that's certainly not equal to 0. So x equals 0 is not a solution. Now we try x equals 7, and we get the square root of 3x plus 4, 3 times 7 plus 4 plus 2 should be equal to x, which is 7. And here we have the square root of 21 plus 4. The square root of 25 plus 2 should be equal to 7. And 5 plus 2 does equal 7. And this is the only solution, the only answer. You see, there were both solutions to the equation after we'd squared both sides, but not to the original equation involving the square root. Problem 8, we want to solve for x. 5 over x plus 3 minus 2 over x equals 3 over x squared plus 3x. Okay, once again, an equation involving fractions. We'd like to get rid of the fractions. We're looking for the LCD. This is x times x plus 3 when you factor it, so the LCD is simply x times x plus 3. I'm going to go through and multiply each part of the equation by x times x plus 3. And in the first term, the x plus 3's cancel. That leaves us with 5x minus, the second part here, the x's cancel. That leaves us with 2 times x plus 3. And finally, the x and the x plus 3 cancel, leaving us with just 3. Okay. 5x. Now distribute the minus 2 through the parentheses. Minus 2x minus 6 equals 3. Or 3x minus 6 equals 3. Adding 6 to both sides. We have only a first degree equation in this case, so we're going to get x alone on one side. 3x equals 9, and dividing by 3, x equals 3. And once again, in a problem involving a fractional equation with variables in the denominator, you should check just to make sure you haven't brought in any extra solutions. And we get, the original equation was this 5 over x plus 3 minus 2 over x equals 3 over x squared plus 3x. And we want to check x equals 3. So we get 5 over 3 plus 3, or 5 over 6 minus 2 over 3 should be equal to 3 over 3 squared, that's 9, plus 3 times 3, which is 9. Okay, here we have 5, 6 minus 4 6, or 1/6. And on this side we have 3 over 18, which of course is also 1/6. So it does check out. And x equals 3 is the answer in problem 8. Okay, in problem 9, we have a system of equations, and we want to solve for x and y. We have x minus 5y equals 16, 9 halves x plus 5 halves y equals minus 3. And as always, I don't like to work with fractions, so on the second equation, I'm going to start by multiplying through by 2 to clear the fractions. So this gives me 9x plus 5y equals minus 6. And my original first equation is x minus 5y equals 16. And I don't have to do any extra work to solve this by elimination. I just simply have to add the equations, and I would get that 10x, the y's are eliminated, equals 10. And dividing by 10, x equals 1. And once I have x equals 1, I can substitute into either equation. Let's say I use the first equation, x minus 5y equals 16. And letting x equals 1, 1 minus 5y equals 16. Minus 5y equals 15. Y equals minus 3. Dividing by minus 5. Okay, x equals 1, 1 minus 5y is 16. Subtract 1 from both sides. Minus 5y equals 15, and divide by minus 5. Okay, so now I want to check this. In the first equation, it obviously works. So that's what we use to solve. Letting x equal 1 and y equal minus 3, I get 1 plus 15 equals 16. In the second equation, I get 9 halves minus 15 halves, which is minus 6 halves, which is minus 3. So it checks out also. So x equals 1, y equals minus 3 for the solution to this problem. In problem 10, I want to sketch the graph of the following equation and label all intercepts. 4x plus 9y equals 36. Well, first of all, we see it's a straight line. Neither x nor y appears to the second power. We have the equation of a straight line. And we're going to get the intercepts.